Mm, cinema. So I already solved some introductory problems last time, so for today we're gonna solve searching and sorting section. We're gonna solve as much as we can and maybe then continue in the next. Let's start. I draw with a mouse, so if my drawing is bad. So we have a drawing pad and we have a we are given a list of n integers of distinct values in the list. Line as a value, the sign as integers x1, x2, print one integer the number of distinct values. So this is quite simple. We need to count the number of distinct values. So what we can do is we can read all the values and put them into a set, and set always has distinct values. So that should give us the answer. So uh, firstly we take the input size, then we input the values, and then we put the values into a set. And there is a very cute trick to convert a vector into a set. So if you're converting a vector into a set, you can just use you can define the set, and then you can pass in the iterators of the vectors to the set. So I can pass v dot begin and v dot end. So what this will do is it will create a set out of the vector using these iterators. So it will create a set from v dot begin to v dot end, and then we can just print the set size. This should give us the answer. I'm gonna cover the complete section, so I'm not gonna leave out problems even if they are as trivial as this one. File is okay, so that got accepted. I think we don't need to think much about that. Reload this, go to the apartments. There are n applicants and m free apartments. Your task is to distribute the apartments so that as many applicants as possible will get an apartment. The applicant has a desired apartment size, and they will accept any apartment whose size is close enough to the desired size. The first input line has three integers. Okay, number of applicants, the number of apartments allowed. The next line contains an integer. Desired apartment size applicant. If the desired size of an applicant is x, he or she will accept any apartment in size between x minus k and x plus k. The last line contains m integer, the size of each apartment, the number of applicants who will get an apartment. Let's first read in the input. Number of people, number of apartments, number of people, size and all the numbers. Size. Again. Then I can just use two pointers, I guess. So for each apartment we can check if someone wants to take that. But the thing is, uh, we'll just do a drawing. So there are n people. Let's say this, I will sort it in decreasing order. Let's say A1, A2, A3. Yeah. And then there are B apartments. Let's say I assign A1 to B2. Like B2 is like, let's say these are very far away, so we just need to care about this pair. So let's say A1 can take both B2 and B1, but A2 can only take B2. Is that possible? Let's say this is A1, this is A2, and this is A1 minus K, and A2 is equal to B2. Okay, so A1 can take both of these, but A2 can only take B2. So if we assign A1 to B2, this A2 will go empty. So we just need to take the first, just need to put two pointers here, just pointer 1 and pointer 2, and just keep going through and just keep on greedily assigning the apartments. If we see this apartment and try to assign it to the first person, to the second person, and so on. This should work. So what the idea is, if there are two people A1 A2 and B1 B2, I should always try to assign B1 to A1 first and then B1 to A2. Because if I assign B2 to A1, there is a chance that B1 will be left empty, and this is not optimal for us, right? And now let's think about it. Okay, so let's say I cannot, B1 is too far away, so I cannot assign it to B1. And then I can just do a binary search. Someone is subscribed. Okay. So should I binary search here? Well, let's do a binary search then. So let's do, oh, let's keep a taken array. I can just erase from the vector. That will be O of n and an m. First, let's solve these. This distinct. Should I keep a multi-set for this? Does not say these are. Should I keep a multi-set for this? Or should I keep a taken array? Well, let's just keep it multi-sig. I think that's overkill, but I cannot see a greedy. Let's keep on. So, what my idea is, for every person, I'm gonna binary search over the answer and just take the leftmost point. Like I'm gonna search for a1 minus k, and I'm just gonna take that. So scene is just don't even need to sort, right? I'm gonna binary do I need to. I think there is a easier answer to. Okay, so for long long is equal to it's gonna long answer is equal to abstract begin start. You can also do a binary search here. People of so this should give me the this should not be long down. So this will give me a iterator, and it is equal abstract new if value of iterator is greater than k will come else. So plus plus abstract. So this should give me the answer. So the answer here is 2, and I'm going to just print it out here. Like C out assigned assigned better to people. So tell me who I'm assigning an apartment. So assigned 60 to 60 and assigned 75 to 8. Correct? Just comment this out. And 10 the power 5, so log n should. Oh, time limit exceeded. And I also got it wrong. Did I not comment that out? Commented it out, right? Hello, bro. Arya. So, and this out. I don't know. I did not have. Maybe I did not compile that first. That, and maybe it was due to the printing error. Maybe I can use integer. And the upon 9, so I can use it. Still getting TLE. Is multiset not fast enough? And let me see. That's fine. So you should use apps.lower bound. I don't know what that lower bound is. So maybe this is better. No idea why, but it is. So let's go to the set now. We have solved two problems. There are children who want to go to a ferry. Maybe just one or two in addition. So the weight of every child, that is so large. Okay, so you are given the number of children and the maximum weight allowed on a. Let's keep an answer here. Let's say maximum weight allowed is X of children is N. Let's say child. So what I should do is I should again keep a multi-set of this, I guess, because we want a binary search again. If I have a x, if I have weight A, I want to search for a weight x minus A, and if there is no such weight, if there is such weight, it's okay, or else I use the lower weight than this. Because this should be optimal, because if I can squeeze in a child, I should always do that. So my idea is sort according to the weights, and if there is a weight A, check if there exists a weight x minus A, because then we can put these two children together. And if there is not a weight x minus A, then take the immediate left element to this, because if this is less than x minus A. Or should I do is, so should I search for x minus, okay, never mind, so just take this x minus A. Or should I keep a map that tells me how many children are up to here, right? What's the size? 10 to the power 9. So this should not work. What I wanna do is I wanna look for element x minus A, and if there is no such element, then I will be somewhere here, and this element will be greater than that, and I can just take the left immediate element, right? And I need to make sure that that element is not this, so I will erase this element first from the multiset. So this should work. So I should just keep multiset again, because it's easier to banish such in a multiset rather than in a vector. Like there's also why I'm using multiset is because it's easier to search in a multiset and delete, while in vector you can search but deletion takes so often. So deletion is very slow in a vector. Let's call this something else, because we already have a x definable. Uh, so so now we have a multiset. Now for file not child dot, I should do is uh, long current is equal to child dot begin. Child dot is I should use a upper bound. That is that should work. I will use upper bound this time. Iterator is equal to child upper bound. I should check that if child is empty here, because I'm deleting an element. Else I search upper bound x minus current weight. This will point me to the next element. This will point me to this element. And if this is s dot begin, then there is no answer. If iterator is equal to child dot begin plus plus. Okay, I should just plus plus the answer. just break it. Iterate is equal to child dot begin. Continue. Else iterator is equal to previous of child dot begin. This is equal to iterator is equal to previous of. First I use previous like this, and then I just choose child dot erase. Then I can just print here what I am using. I can print here cout payout. Current. So answer is 4 because the runtime. And now I got it. So it's okay. Current is equal to child dot begin, child dot erase. I should check it. Error is still not working. But this should not break. Yes, it will still give the same error. Now I need to error. Like I can use Where is this error coming from? Input again. And there's errors these lines. Upper bound is correct. Or should I just use a 2 pointer? Should I just use a 2 pointer then? I want to solve it using this. I can use a 2 pointer if I want. Like I can use a 2 pointer. There is a look for element minus a and just keep on pairing these. And there are some leftover elements. Keep adding them to the answer. But what's the error here? Yeah. Okay, so it is yeah. Just previous work on it, right? Working correct. Is working correct. Problem is the else loop. That's not it. Paired 2 with 9. So this should not be the case, right? 2 should not be paired with 9. Then so I have to use that. So now it's looking fine. It's all because of this line. I thought using previous iterator all automatically move the iterator to the previous point. Yes, iterator. Whatever. Wasted like 50. Let's try and submit. Hello, bro. Set. Let's We have solved like 3 problems for now. Concept 5309. So this will be the last problem for the stream, and maybe we'll just continue solving these. Let's solve this last one. Stream is already like 40 minutes now. So there are n consecutive less than n customers. Each customer announces maximum price he or she is willing to pay for a ticket. For a ticket first in number of so code for is fixed. Having some issue and I was solving. So let's wait for it to run. Okay, so there are n number of tickets and the number of customers. Input that. And then get customers. Getting DLE'd. Why is this getting DLE now? Because of the maps. And log n to n plus n into log scale. Yeah. Maybe I should just use vectors here, maybe. Just initialize with the -1. Should I fix this first? Let's just solve this problem and then I will solve the core forces one and then I'll just exit the stream. So there are n concert tickets available. The stream is still going live, right? There are n concert tickets available each with a certain price. Then n customers arrive after another each customer of this. Let me take a print this one. Okay, okay. So let's think about it. Just a very possible price. But does not again problem with multi-sets, I reckon. Let's just keep the customer prices or ticket prices. Should prices? Yep. Let's keep the ticket prices in the multi. Multi-sets are really helpful binary search and it's kind of upper bound, lower bound. So, but they get an extra login factor, so be careful. 10 per day and certain ticket. So now let's think about this. Let's say there is a ticket T1 and there is a customer T1 with price this and C2 with price this. So suppose we should start with C1 and then with C2. Can there be an inverse case? Yeah, if there's I'm thinking about a ticket that is less than this, I will upper bound on T, then just take the lower one. And if there was someone like customer here, they would have already taken this. They should be. But that is if there's good work. So sort the customers. Uh, but this should be a vector, and I also need indexing. And the second, the safety of second should be. I can keep track of the. So for auto experiment prices, something like. And what do I want to do next? I want to upper bound. So auto iterator is equal to x dot above the ticket dot above. The price is I can search for x dot x. I can search for price. If iterator is equal to it dot again, that means there is no price less than answer of this. And I should check if ticket is an price answer. Is there any constraints on an endem? Yeah, so there can be like some tickets get empty. If ticket is equal to this, or it is equal to 1 L iterator is equal to previous one iterator. Assign the we need to assign the price. Answer of ID is price, and then I can just erase it from the ticket. And then for auto external print. What? Okay, another one of this. Oh man, this debugging takes forever. What's the error now? So expand to I'm assuming it's after this has to be the answer thing. It is hmm. M is the number of tickets. Or M is the number of tickets I have made. Is the okay, so and I have the wrong. What I'm doing, did I so there are 5 people, right? Or there are 5 tickets. Have there. It's a person with the ticket 3. You should have gotten the 3 one. Why didn't you get the 3 one? Didn't I saw it? The Brooks debunk thing. So I sorted, right? Yeah, so I did everything correct. Where's the just check this. This is a class on how to debug. So this contains three. This solves the program ever. I don't think I have to debug a multi-set. This should give me an error. I need to add this to debug a multi-set. Yeah, this is correct. Read out this. Why is this minus one? Bro, why is this minus one? What the fuck am I doing? Print for each customer the price that they will pay for the ticket. After this, the ticket cannot be purchased again. So do I have to like? Do I not need to sort? So every customer purchases one by one, so I don't need to sort. Is that it? Bad wording to the problem, bro. So you don't need to sort every customers first. This will announce, then this, then this. Like you don't need to. Maybe I cannot read problems, or this is very poorly written. So I don't need to sort this. Right. So this was very poorly written, to be honest. So I think that is it for today. A very badly written problem, on, or maybe a reading mistake on my part, whatever it is. So it was like a 1 hour stream, and I saw like what was there, like 4 problems that were like quite easy. I just had a lot of debugging issues and I read this problem wrong, so that was that. Let me close this and now let's just try to solve the problem like I was doing earlier. So this is a problem on Chinese remainder theorem. I'm getting a TLE and I believe that is because of the maps. Right, so this, and now the thing is, instead of using maps I have to use here, because number can be 2 times max of n or m. So I use, let's say, constraint position of A, this should be less than n, position of B, this should be less than this. So the only map I need is solution. So because I don't even need that, because this should be 2 times n. So let's keep along, say, max of n or m. This is a vector. Long 2 times c plus 5. Right, so this should give me position of that element. This should give solution should give end area. And that should be because n into m, this can be co-prime and this cannot be, this has to be a long number. And if we should, this number is equal to continue solution, this should, this is a div 1b problems like 2200 quite hard. Also I have to change some long twins. Maybe that extra map vector. If it's still TLEs, yeah. This is very slow, like 13, 15, 10 minutes, 2 seconds. So yeah, this is okay, but those maps were like killing me right here. So yeah, so this is correct. And this map thing was Like maps add an extra login factor, so if you are TLing on a problem really hard, this may be due to extra log factor, so try to remove if you can. Also, before I close today's stream, I should push the CRT file to make it a repository. So edit Chinese remainder. Gone. So yeah, was it for today's stream. So bye bye.